Over the years, robots have gotten quite good at identifying objects, as long as they're out in the open. Discerning buried items in granular material like sand is a taller order. To do that, a robot would need fingers that were slender enough to penetrate the sand, mobile enough to wriggle free when sand grains jam, and sensitive enough to feel the detailed shape of the buried object. MIT researchers have now designed a sharp-tipped robot finger equipped with tactile sensing to meet the challenge of identifying buried objects. In experiments, the aptly named digger finger was able to dig through granular media such as sand and rice, and it correctly sensed the shapes of submerged items it encountered. The researchers say the robot might one day perform various subterranean duties, such as finding buried cables or disarming buried bombs. The research will be presented at the next International Symposium on Experimental Robotics. The study's lead author is Radhen Patel, a postdoc in MIT's Computer Science and Artificial Intelligence Laboratory, CSAIL. Co-authors include CSAIL PhD student Branden Romero, Harvard University PhD student Nancy Ouyang, and Edward Adelson, the John and Dorothy Wilson Professor of Vision Science in CSAIL and the Department of Brain and Cognitive Sciences. Seeking to identify objects buried in granular material, sand, gravel, and other types of loosely packed particles, isn't a brand new quest. Previously, researchers have used technologies that sense the subterranean from above, such as ground-penetrating radar or ultrasonic vibrations. But these techniques provide only a hazy view of submerged objects. They might struggle to differentiate rock from bone, for example. So, the idea is to make a finger that has a good sense of touch and can distinguish between the various things it's feeling, says Adelson. That would be helpful if you're trying to find and disable buried bombs, for example. Making that idea a reality meant clearing a number of hurdles. The team's first challenge was a matter of form. The robotic finger had to be slender and sharp-tipped. In prior work, the researchers had used a tactile sensor called GelSight. The sensor consisted of a clear gel covered with a reflective membrane that deformed when objects pressed against it. Behind the membrane were 3 colors of LED lights and a camera. The lights shone through the gel and onto the membrane, while the camera collected the membrane's pattern of reflection. Computer vision algorithms then extracted the 3D shape of the contact area where the soft finger touched the object. The contraption provided an excellent sense of artificial touch, but it was inconveniently bulky. For the digger finger, the researchers slimmed down their GelSight sensor in 2 main ways. Thanks for watching. Please subscribe my channel for more updates.